Now, maybe you're curious, why are we using multiple uplinks connecting to our router? Is this a good design? The answer is no, it's not a good design. You will rarely see this. In a traditional network, you're not gonna use a router communicating from one VLAN to other VLANs. Most of the time, you will be using a layer 3 switch. So what I'm gonna do is I will remove this router and I will replace this to a layer 3 switch icon. There you go. So this is our layer 3 switch. And a layer 3 switch has all of the capabilities of layer 2 switches, but can also do routing functionalities. So in this case, I can use E1 and E2. I can convert this interface from a switch port, which is layer 2 ports, to layer 3 ports. But I'm not gonna do that because based from our previous discussion, it's better to have one link from one device to another, okay? We don't want to create multiple uplinks where the number of uplinks is equivalent to the number of VLANs. Bad design. So what I'm gonna do is, instead of multiple uplinks for VLAN 10 and VLAN 20, I will create a trunk port, okay? Trunk or 802.1q uplink, okay? And as what we have on the other side, it will carry VLAN 1, VLAN 10, and VLAN 20, okay? Same scenario, but instead of switch 2 as layer 2 interface, layer 2 Ethernet switch, this is a layer 3 switch. Okay, let me change the color. This is now a layer 3 switch. Okay, there you go. Now, maybe you're thinking, how about the interfaces? What interfaces shall we use? Now, this can be, let's say, it doesn't matter. Ethernet 8, okay? So switch 1 and switch 2 has the same interface name, Ethernet 8, as their uplink. This is also a layer 2 trunk, okay? So this is trunk. This is trunk. Now, how about this network? How about the default gateway? In this case, we're gonna create what we call the SVI, or the Switch Virtual Interface. Now, how we configure this is pretty basic. All you need to do is create a logical interface named interface and then the VLAN ID. So in this case, we have a VLAN 10. And by the way, we need to also create VLAN database on this layer 3 switch. So in its VLAN database, it should also have VLAN 10 and VLAN 20. Okay, now what I would like to highlight is that the SVI switch virtual interface, this is basically a VLAN that has created a logical interface with an IP address. So basically this is our SVI, okay? Interface VLAN 10 with an IP of 192.168.10.254, which is the default gateway of PCA and server C. Now for the other network, what I'm gonna do is I'm gonna assign this IP address to interface VLAN 20, okay? So interface VLAN 20 has an IP address of 192.168.20.254. Again, this IP address is our default gateway. Now it is assigned to an SVI, or a logical interface VLAN. Now, how about the routing table? We're not using interface E1 and E2 anymore. How does it work? Well, here's how it works. The routing table, since it doesn't have interface E1 and E2 anymore, these two networks will still be added to its routing table, okay? We still have two entries, 192.168.10.0 and 192.168.20.0/24. But this time, this is learned via the SVIs. So you will see here, interface VLAN 10, okay? And interface VLAN 20. Now, here's how it's gonna work. If PCA needs to send traffic to, let's say, server D, PCA knows that the destination is a different network. It will send it to the default gateway, okay, which is 192.168.10.254. Now, this is a different case because we have a trunk link from switch 1 to switch 2. So the trunk link, it will receive the traffic as VLAN 10, and in this case, it will decide whether or not to forward the traffic to a destination, and it again will rely to its routing table. So the destination is server D, 192.168.20.0 network. It will look to its routing table, and let's figure out, do I have network going to 192.168.20.0? As a matter of fact, yes. Okay, this is learned via interface VLAN 20. So what will happen is, okay, I will forward the traffic to this logical interface 192.168.20.254, which is again mapped to this trunk link. When we say trunk link or trunk interface, by default it will process all VLANs. So think about this as a trunk that's doing encapsulation. But before it does encapsulation to VLAN 20, before it sends to switch 1, it has to check this routing table first, because we're trying to do intra-VLAN communication from VLAN 10 to VLAN 20. Okay. Now, as it decided, hey, I can reach VLAN 20, it will now forward to interface VLAN 20 and then do its encapsulation and forward it to the physical interface, which is E8. Send it to switch 1, and switch 1 will forward it to the destination, which is server D. So that's how you do intra-VLAN connectivity using a router and using a layer 3 switch.